Today, let's learn about how Elasticsearch works internally, clusters, nodes, and shards, and its replicas, and all other nodes. Before we talk about shards, replicas, or performance, we need to understand one core idea. Elasticsearch never runs as a single thing, it always runs as a cluster. So what does it actually mean? Elasticsearch runs as a cluster. A cluster is simply a group of Elasticsearch nodes working together. Think of it like a team where each node is one big Elasticsearch process which usually runs on a single pod or one single virtual machine. Together they store data, they answer search requests, they keep the system running even if something fails. Inside a cluster, Elasticsearch keeps track of which data exists, where that data lives, which nodes are healthy, which nodes are responsible for what. This information is called the cluster state. What is cluster state? The cluster state is like a cluster's shared memory. It contains things like list of all the nodes, all indices, shards that we had learned about in the previous video. And all of this brings us to the master node. The master node is not about heavy work or data processing. Its job is coordination and decision making. Its job is to ensure keeping the cluster state updated, deciding where shards should live, handling node joins and failures, managing index creation and deletion. Think of the master like the manager who doesn't do the work but makes sure work is assigned correctly. And in the scenario, if the master goes down, the cluster elects a new master. Data is not lost. Searches may pause briefly, but then it will resume. Now that we understand clusters and masters, let's talk about node roles because not all nodes do the same job. We have already talked about the master node. So let's move on to other node roles, data nodes. Data nodes store the actual data, and this data is split by temperature. Hot, frequently written and queried data, for example today's logs. Warm, less frequently accessed, for example last month's logs. Cold, the data that is rarely queried, could be 6-month-old logs, and the last would be frozen, which signifies almost archival data. For example, the data that you would want to store just for the compliance purpose, but it's not being queried anymore. And this training exists to save cost, improve performance, and match hardware to usage. Then comes down to ingest nodes. Ingest nodes process data before it is saved. So it's mainly used to parse logs, add geolocation, rename fields, and do a lot of things. Coordinating nodes. This role is often misunderstood. A coordinating node receives client requests, breaks them into smaller tasks, sends those tasks to data nodes, collects results, and returns the final answer. Every node is a coordinating node by default, but in large clusters, you may dedicate nodes only for coordination. And now we know that who does what, and let's talk about how data is stored. So now learn about why shards exist. Elasticsearch cannot store large data sets as a single chunk, so it splits into shards. A shard is not a replica. Instead, it's breaking the actual data into smaller parts. It's a smaller piece of an index. So example, if you create an index and you say, I'll go with 5 primary shards. So logically, you are splitting your data into 5 logical parts, and these parts can live on different nodes. Why this matters? Data can grow beyond one machine. Searches can run in parallel. Performance scales horizontally by implementing the shard. But having a high number of shard is not always the best solution, because having a high number of shard may also increase the search latency. Now let's connect everything and understand the read and write flow within Elasticsearch, because we have already learned about the node roles and shards and replicas. So let's focus on read and write flow. Now let's assume there's a client who made a request, and the request would start from your client and it will go first to the coordinating node. Now coordinating node could be any node, or if you have decided or defined it, then the specific nodes will receive the request. The flow for the write path will go like: coordinating node receives write request, it figures out which primary shard owns the document, it sends request to that primary shard, then primary writes the data onto itself, and meanwhile replicas copy the data. An acknowledgement is sent back to the coordinating node and then to the client. Now let's talk about read path. Read path, we usually deal with read path when we are searching anything. So again, coordinating nodes are going to receive the search request. It sends the query to all relevant shards, be it primary or replica. Each shard executes the query locally, and then results are sent back to the coordinating nodes. Coordinating nodes will merge them, sort them, and return the final result back to the user. This is also called as scatter gather, and that's how Elasticsearch can search massive data sets quickly. If this video clicked for you, like this video and subscribe for the next part where we'll move into much deeper components like Elastic Agent, Fleet, and modern observability architecture. Do make sure to subscribe and like the video. Thank you.